as we continue our exploration of trigonometric functions and so forth, I want to introduce you to the unit circle. And the unit circle is something that will help us look at any angle that we want to explore when we look at these trigonometric functions. So yeah, you try saying that a couple times. So up here I have a basic circle. And one thing that we're going to suggest here is that let's look at the radius being 1 in this particular circle. So I have a circle of x squared plus y squared equals 1, such that the radius is 1. When that happens, we can take our arc length formula, which was its arc length equaled its radius times its theta. And if its radius is 1, and then theta, in this particular case, I'm going to use just the angle t. The 1 unit basically drops out, so my arc length becomes the same measure as its radian. So if its radian measure is t, its arc length is also t. And I know that doesn't seem real phenomenal to us right now, but what it does is it helps us kind of identify some additional angles and explore and work with additional angles when the radius is 1. So watch how this works out. So that being the case, we can redefine our trigonometric functions such that sine of t equals y, cosine of t equals x, and then we can unpack the other 4 from there. Another way I like to think about that is if we remember our triangles back a couple of sections. And if you can see this triangle that I have here and my particular angle, do you remember which was sine? Sine was the opposite over the hypotenuse. So sine was this height over the hypotenuse. If the hypotenuse is 1, the sine just becomes that height. And on a Cartesian coordinate plane, which one, the x or the y, represents its height? Well, the y does. So the sine of t equals the height of the triangle. And the cosine of t, well, that was the adjacent over the hypotenuse, which is basically the length or the width of that triangle. And in this particular case, those are the x variables. So if we can move on from here, we're such that the sine of t, or the sine of any angle, is its y coordinate, and the cosine of t of any angle is its x coordinate. And then we can unpack the rest. So let's imagine then that we have a unit circle. And on that unit circle, we're given a particular point that we want that develops an angle. So I have a point that says -1/2. So this part right here is about -1/2. And its height is √3/2. So I have a point on the unit circle. Its x coordinate is -1/2. Its y coordinate is √3/2. And from that, can we develop the 6 trigonometric functions from here? And I think we can. So let's identify. We know that our x equals a -1/2. Our y equals a √3/2. And the radius, it's a 1. So we can just kind of let it just be its own little self. So the sine of t, the sine of this angle that's defined by this particular point on the unit circle, is its height, or its y coordinate. So the sine of this t equals √3/2. Its cosine, cosine is the x variable. And its x length, or its x variable, was defined as -1/2. And we kind of remember that it was negative because cosines in the second quadrant, they were negative. And the third quadrant. The tangent of t is its y coordinate over its x coordinate. Y coordinate, negative or a positive 3/2 or √3/2. All over its x coordinate. Its x coordinate was -1/2. And then remembering how to deal with some complex fractions, we reduce that down, and that reduces down to -√3. And then from there, we can find the other 3 is just as easy as well. We can find our cosecant. let's do one more here for us. It's cosecant equals 1, which is its radius, all over its y, which is root 3 over 2. To manipulate that algebraically, let me work on it up here. Cosecant of t equals 1 over root 3 over 2. That equals 2 over root 3. I can't leave the root in the denominator, so I need to rationalize the denominator. Multiply both the top and the bottom by root 3 over 3, root 3 over root 3, and that equals 2 root 3 over 3. And so my cosecant of this particular angle, as defined by this point, negative 1/2 and 3/2, root 3 over 2, its cosecant is 2 root 3 over 3. And then likewise, we can do that with secant and cotangent as well.